So, hello guys. Today we are going to start with the first algorithm itself. Okay, that is a linear regression. So we are seeing the basic things related to machine learning initially, and we'll start with some basic algorithm today. Okay, so there are number of models. Models. Those are there like linear regression is there, logistic regression is there, k nearest neighbor is there, decision tree. Number of models are there. We'll start with the basic one, that is a linear regression first. Okay, so we'll see the theoretical concepts today. Implementation of linear regression will execute in upcoming session. But what is the theory behind it? How it works? Mathematical intuition behind a linear regression that we will cover today. It will be simple to understand. Okay, so number of things we have learned before as well. There are some input variables, correct? There are some input variable and output variable. Suppose I'm predicting a salary, so it depends on the person's experience, person's age, maybe qualification, maybe from which stream he or she is. So that will be your output. And whatever we are taking into the consideration, age, experience in years, domain, that will be an input. Okay, so there is some relationship between input and output. And unless and until there is no relationship, we cannot build any model. Right? I hope you are getting this thing. Suppose sepal length change, petal length change, then it should affect the species according to the sepal length, sepal width, petal length, petal width. Because these four are the input, species is your output. So there should be some connection, there should be some relationship, right? So the first algorithm that we are going to cover is linear regression, which is a type of supervised machine learning algorithm. Okay, so there are three types of machine learning: supervised, unsupervised, and reinforcement. In that, initially we will go with the supervised machine learning algorithms. So this is the first algorithm from the supervised one, where we know what is the target, what we are going to predict, that we know. In that, this is the first algorithm, that is a linear regression. And in this case, your output nature will be continuous. Whatever I will predict, suppose salary I will predict, sales I will predict, I can predict the price of something, price of a vehicle, price of a flat. So if continuous output is there, that will fall under the regression. And why it is a supervised? It is supervised because we know what we are going to predict: flat price, house price, salary, sales. That thing we know what we are going to predict. So that target is known in case of a supervised. So data is labeled and input output pair is there. Is it? I hope this thing is clear. In supervised machine learning algorithm, input and output mapping is there. For this input, this is output. Is it okay?
Yes, sir.
Correct,
Yes, sir.
Bhavya?
Yes,
Is it
sir.
making sense?
Yes.
So linear regression is a supervised machine learning algorithm used to predict. Okay, used to predict a continuous numerical value. Correct. It is not like diabetic, non-diabetic, spam, not spam. For this, we cannot use a linear regression. When linear regression will be used in order to predict a continuous numerical data. Is it okay?
Yes, sir.
So it established the relationship between dependent variable, that is output, and one or more independent variable. Input variable may be any number. It may be a one input variable, there may be a two input variable, three input variable, four input variable, like that. So for example, what I am predicting, suppose I am predicting the house price. So house price is my output. Okay, and what can be the independent variable or input? There may be a square feet. There may be a number of rooms, number of bathrooms.
Area.
Okay, area, on which floor it is. Like these things will affect the price. So price is my output, which is single one, and there may be one or more independent or input variable. Right. So the algorithm models this relationship by fitting a straight line to the data points. So what it will find, this straight line is nothing but a base fitted line. So it will be like this. Suppose what we will have. Suppose on this side, on the x-axis and y-axis. Suppose x is your input, where it is I'm taking it as an experience. And on y-axis, what I am predicting? I'm predicting a salary. So there will be some linear relationship. As experience increases, salary increases. Okay. So this, suppose whatever data points are there, 100 data points are there, 100 records are there for experience and salary. And if we plot the those data points with the help of some graph, so it should give some best fitted line. And if I'm asking for a new experience, suppose for a 9-year experience, what is the salary? So that should be among that line, along that line, or along that line somewhere. Okay, so that we can find out with the help of this best fitted line, and it should have some relationship between input and output. So what is the main objective here? The main objective is to minimize the difference between the actual value and predicted value. Whatever actual value is there, suppose there is some actual value for 9-year experience, which is giving you the suppose 19 LPA. For example, actual value is 19 LPA. And if I ask to the model, if I build the model with the help of a linear regression, so that value should be close around. It should be like 18 LPA or like 19.5 LPA or 20 LPA. So what I can find out, model will decide that based on the best fitted line. So where it belongs. So that actual value, suppose actual was a 19, and predicted value for the salary is a 18 or a 19.5. So that difference should be a base. What is the difference? Actual and predicted value difference, that is nothing but error. So you will come to know all these values. Don't worry about it, or don't bother about it right now, because we are going to discuss these things number of times in upcoming sessions. What is the error? What is actual? What is predicted? So right now, what is actual? We have explained this in a true negative, true positive, that thing, right? Type 1 error, type 2 error. So suppose actual value was a 19, and what your model is predicted 19.5. So 0.5 difference is there. That is the error. So 19 is like actual minus predicted. The difference will give you the error term or a difference. Okay. So linear regression is widely used because it's very easy to implement, interpretable, and effective for the problems where data shows the linear trend. Whenever there is a linear relationship between input and output, linear regression is the best choice. Is it okay, guys? Number of algorithms are there, many algorithms are there. This is very basic algorithm, but it can give you the best results. Depend on the data. If your data is having the good linear relationship between input and output, linear regression will work fine. Okay. So this is some introductory part about a linear regression, how it actually works. For example, what I am predicting, what is input? Experience is input. Generally, just give it with the help of capital X. Just keep in mind, guys, in order to define input, we are using a notation capital X, and output, that is a salary, small y. So this is the problem of simple linear regression. What is the problem is simple linear regression, only single line will be there, right? Now, 2 dimensions are there only. One is a year in experience, and one is a salary y. So we'll get a line, and whatever experience is there, those values are given. Okay. Those values are given, like whatever orange color values are, those are experience values. The best fitted line that will cover the most of the point among that. So suppose 100 points are there, the line will give you the 90 points, 95 points, 85 points. Those are matched. Simple linear regression uses one independent variable. If there is only one input, output will be always one, right? In all the cases, output will be always one. Yes, but if input is one, it's a simple linear regression. And if output are more than one, like in case of house price, there may be area, there may be number of rooms. So 2 inputs are there. How many inputs are there? 2 inputs are there. That can be called as the multiple linear regression. That's simple. Okay. Is it okay? Only one input and one output is there. It will be a problem of simple linear regression. If more than one input values are there, area is there, rooms are there, room size, number of bathrooms are there, area, location is there, number of floors are there. So that will be a case of multiple linear regression. So area is there, location is there, rooms are there. So all these points are plotted like this. So it is not directly giving the linear relationship. Non-linear relationship may be there. So sometimes we can use the linear regression, or other methods are also there, support vector machine like that. Those we will see in upcoming sessions. But right now, just try to understand, if your equation is like this, simple, y equal to b plus or b naught plus b1x. If you are like, if it is hard to remember, you can simply write y is equal to mx plus c, this equation as well. Okay, so you can try to understand with the help of this also. B naught or like b0 is nothing but intercept value over here. What is b naught? Intercept value. What is a b1? b1 is the slope of a line and x is the input. X is the input. So this formula is for the simple linear regression. If we write this formula with help of this, b naught plus b1 x plus or b1 x1 plus b2 x2 plus b3 x3, like number of inputs are there, house square feet is there, room sizes is there, number of rooms are there, so that will be a problem of multiple linear regression. You can remember any equation y equal to mx plus c. If it is feasible, you can go with that. If you want to use this y equal to b naught plus b1x, b naught is nothing but intercept, because it will not start if like b1 is a 0 slope. If b1 is a like slope is a 0, or like y b naught is there, y b naught is there, you will find this equation like this, right? Now line is always starting from somewhere, it is not starting from 0, right? So for some input, output should be, if like slope become a 0, value of y when x is a 0, right? Now this is value of y at this point. What is the value of y? Suppose 2 is the value of y when x is equal to 0, correct? Why it is given? Because in some case, if the slope value become a 0, right, with the help of this, if you are not taking this into the consideration, value will become like this, b1x. In some case, if slope is a 0, for some input, you are predicting a salary, experience is a 3, correct? So it will become 0.
Yes.
For 3-year experience, salary will be predicted as a 0. That is not correct, right?
Yes, sir.
So for that reason, that intercept is given. At least 2 will be there. Is it okay, guys?
Yes, sir.
For the particular output, that value is taken into the consideration, that intercept is there. So like notation for this is dependent variable, that is the output, independent variable, that is the input. B naught is your intercept, that is the value of y when your x or input is a 0. B1 is a slope, that is for change in a y, or change in a y for a 1 unit, change in x, like dy by dx, that value is there, difference along x and difference along y. The goal of model is, what is the goal of model? Is to find the best values of b1 and b0 to minimize the prediction error. On which value this equation y and x relationship is defined with these two coefficients, that is a b0 and b1. So that should be best values. What I am talking about, best values, not a minimum and a maximum. Best, that is optimum values. It may be maximum, it may be minimum, but it should give you the minimum error. So that prediction will be with the help of this equation, yp is equal to b0 plus b1x. Values will be predicted with the help of this equation. Those will be calculated, or like those will be compared with the y actual value, and this difference will be error, and this error should be reduced, or it should be less. That is our goal. Is it okay? Any doubt till now?
No, sir.
No, sir.
Is it going good? Have you revised something regarding this?
No, sir.
No, I hope it will like, it is understandable, right?
Yes, sir.
Or it is going
Yes.
like on a high level. Are you getting this?
Yes, sir. The flow is okay.
Okay, fine. So how it works actually, right? So it works by finding the best fitted line. Right now, suppose this is the best fitted line, that is find out, or y equal to b0 plus b1x. So this predicted value is there. You will find, your model will give you the best fitted line for b0 and b1, and for x value we can input right now. So with the help of this, suppose I need to calculate for a 9, so it will be taken like this. Suppose this value is there, 3 is there, slope we have given something 0.2, 0.3 like that. So yp is equal to, it will be in this case 3 plus suppose 1.8 or that one. So 4.8 will be your prediction for 9-year experience, 4.8 LPA like this. So this equation will be used for the prediction. But how it is find out? The best fitted line is found with the help of all the like things where model will give you the minimum error. What you need to minimize? What you need to minimize? Minimize the error. Okay, minimize the error, or where it is taken into the consideration error square. Why error square? Because it is y actual minus y predicted for 1 point, for a second point, for third point. So this is summation is there right now. So sometime this error will be like, it may be possible -1, again this will be +1, this will be -1, correct now? So in order to like avoid the 0, sometime it happen -2 -2, it will become 0. So for that it is taken into the consideration square. So squared error difference is there. Difference of squared error is taken into the consideration. So best fitted line that represent the relationship between the input and output variable. So what is input? Suppose experience is your input, salary is your output, and that relationship is represented with the help of a best fitted line where error square is calculated. Okay, and it predicts the values using the linear equation, which is, what is the linear equation? Yp is equal to y predicted is equal to b naught plus b1x. The model calculates the difference. What is the difference? Error between the actual values and predicted values. So this will be given by a model. For the same thing, you will have some actual value. Suppose actual was a 9 and predicted is a 9.5. So difference or error is a 0.5, and it uses the least square method. Take a least square of each value to minimize the error and minimize the sum of squared error. How sum of square is taken into the consideration? Summation of y actual minus y predicted, square of all these terms divided by number of data points. For how many data points that error is calculated. So that is known as sum of squared, and they determine the optimal value of a slope and intercept. So what is the slope? B1 is your slope here. You can take it as a m. Intercept is a b naught. You can take it as c as well. If you are writing a regular equation, y is equal to mx plus c. So c is the intercept, m is the slope, x is the input. What we have written, y is equal to b naught, that is a slope, intercept, b1x, b1 is a slope, x is the input value. Okay, so our ultimate aim is to find out the optimal values or best values for b1 and b naught and minimize the error. Okay, so same time it will have some assumptions. What are those assumptions? There should be some linearity. So these are the assumptions, like in after 3 years as well, like for three years data scientist experience, machine learning engineer experience, data analyst experience, people are asking what are the assumptions for linear regression? Because whenever we need to build a model, before building the model, we should have like understanding of that algorithm, right? Theoretically, we should know what that algorithm contain, what are the like features of that algorithm, when we can use it, when we cannot use it. So before working on a linear regression, we should have like idea about the assumptions. What are the assumptions? Linearity is first assumption. What is the first assumption? Linearity. What is meaning of linearity? There should be linear relationship between independent. What is independent? Input. Experience is your input and dependent variable. If experience increase, salary should increase. So it may be a positive relationship, it may be negative relationship, correct? But there should be some relationship between input and output. Is it okay? There should be some relationship between input and output. It may be positive, it may be negative. If price increase, demand may decrease, right? For more price, demand is less. So it is a negative relationship. But there should be some relationship in between input and output, independent and dependent, feature and target. Three different words are there. If you are taking input variables as a feature, output will be a target. Is it good? Is it going good? I hope you
Yes.
are getting this. Okay.
Yes.
Then there should be some independence. Where it should have independence? Observations should have or should be independent to each other. What is observations? Like input variables. Like there should not be relationship between inputs only. Suppose price is there, okay? Price is your input, and sometime it is given in a dollar, sometime it is given in a rupees. 2 columns you are having for a price, so it will have a relationship. or it will create a, what is like, suppose $80 is given, so $80, and if you take it in a rupees, it may taken as a $1, right? So it will create a confusion for a model. So it should be converted into the single value. There should be no dependency in inputs only. Input should be like independent on each other. There should be dependency between input and output. There should be no dependency between inputs only. This is a sentence. Input and output variable should have a relationship between them. There should not be any relationship between inputs only. I hope you are getting this, correct? Next, third assumption is homoscedasticity. So, meaning of a homoscedasticity, that constant variance of errors across all the levels of X. So, for all inputs, the variance of errors. So, whatever you are calculating, that error variance should be same for all the X values. So, there is known as the homoscedasticity. If your X values are giving different errors, so it can be called as the heteroscedasticity if that variance is not constant. So we can calculate the variance, right? How values are varying. Correct. Variance is just a square of standard deviation. You can calculate very easily. So these things are there. If we plot the like errors graph with the help of KDE plot, if we calculated the error for all the data points, suppose 100 data points are there, for those you have calculated the error y actual minus y predicted, so you will have 100 terms for the error. And if we plot the graph of those 100 values, it should follow the normal distribution. The residual should be normally distributed. What is the residual? Residual that means difference between actual and predicted value, correct? So that should follow the normal distribution. I hope you know normal distribution.
Yes, sir.
Normal distribution, that is a bell-shaped curve which is following like maximum values are around the mean only. So mean of that particular error value will have like major density over there. Again, no multicollinearity, that is like similar to independence. Independent variables should not be highly correlated. There should not be any correlation between input only or independent variable, and no significant outliers. So extreme values can affect the model accuracy. Suppose age column is there and some values are like 250, 350, minus 50. This is not allowed in case of linear regression. Very simple algorithm is there. Very simple assumptions are there. Very easy to understand. Very easy to understand. Linearity, independence, or no multicollinearity. You can combine these two. There should be independence or a no multicollinearity between input variables, independent variables. There should be homoscedasticity for the errors. That is, constant variance should be there for all the levels of X for error values, and normal distribution of errors. If you are plotting the errors, it should follow the normal distribution and no outliers are allowed. This is very basic algorithm. Please keep in mind, this is very first algorithm, basic algorithm, so it is not working well with the outliers. Is it okay, guys? Very simple to understand, okay? And very easy to learn as well, okay? Some applications are there. House price prediction, so we can estimate the property prices based on the area, okay, or location and features. If we want to forecast the sale, we can predict the future sales using the past sales data. If we want to analyze the stock prices, that also you can call analyze the trends and predict the stock prices. We can demand the forecasting, risk assessment, business growth analytics is there. Okay, so these things are there related to linear regression. If we talk about the advantages, so it's very simple and easy to implement. Okay, it's very simple and easy to implement. Basic mathematical understanding is sufficient. If you are working with this example only, y equal to b naught plus b1x, like intersect, or you can write as a y is equal to mx plus c as well. If you are like familiar with this example, like equation, you can work with it. It is very easy to interpret. Coefficients clearly show the impact of independent variable. These two coefficients are there, m and c, or like b1 and x, and that values are like giving the relationship between input and output directly. Very fast computation is there, low complexity, no complexity is there, nothing, very simple. Only whatever you are working, that is depend on this equation only. So it is very less complex, no complexity is there. So if you are having very large data set with a low complexity, it will give you the very fast calculation. Works well with the linear data only, right? This is advantage, and sometimes it is a disadvantage as well. If your data is not linear, it will not work properly. So it provides the accurate results when data follows the linear trend. Less computational power is required, obviously. Compared to the complex algorithm, it will take the less time in order to predict something, in order to give the predictions useful for the prediction and forecasting. So whenever your output is a continuous, this will work well. Okay, then same time it will have some disadvantages, like assumes the linear relationship, so not suitable. If your data is following non-linear data pattern, it will not work well. Sensitive to outlier, that we already discussed. Extreme values can significantly affect the best fitted line, that will deviate. Right now, suppose most of the points are like this and line will be like this, and some point is there, so line will be deviated. So it will be like in this region, most of the point are here, and because of this point, this line is shifted. So it will give the whenever you are predicting something, YP will be based on this line. So all results will be like gone wrong. Correct? Are you getting this?
Yes, sir.
Correct? Again, multicollinearity issue is there. Multicollinearity. What is in multicollinearity? High correlation between independent variable reduces the accuracy. If your inputs are related only, input values are related, input variables are related to each other, it will create a issue. Homoscedasticity assumption is there, which is unequal variance of errors can affect the model's performance. Okay, so these some disadvantages are there. So all these things are there related to linear regression, guys. Okay, in order to check the accuracy, so there are some, what we can say, just a minute. So just if you want to write down, you can just write down. I am not going to give the formulas. There is something called as the loss function for regression. So this will be used for linear regression or any regression problem. So for KNN regression also it will be the same. For decision tree regression also it will be the same. So loss function that are used to calculate the error. Okay, sum of squared error, we have seen something, right? So in that first one is a MSE. Okay, mean squared error. Those we will use while like evaluating the algorithm. Mean squared error is there. Mean squared error is there. Second is root mean square error is there. So it is just a square root of this above, root of MSE. And third one is a MAE, that is a mean absolute error. Mean absolute error. How it is calculated? If you want a formula, it's very simple to write a formula. Suppose MSE is equal to summation of I is equal to 1 to n y actual minus y predicted bracket square divided by n. N means how many data points are there. So suppose there are 100 data, summation of 100 actual values and 100 predicted values, different square, and its summation divided by 100. Its square root will be RMSE, just a square root of that value, MSE. And what is the mean absolute error? Mean absolute error is a summation of I is equal to 1 to n. Instead of a square, mod will be there, modulus divided by n. So if minus 1 is there, it will be plus 1. If plus 1 is there, it will be a plus 1. Simple. So in order to calculate the error, we are using these three loss functions. If somebody asks you, what are the loss functions in a regression? It is for any regression problem, linear regression or any regression based algorithm. So it is a mean squared error, root mean square error, and mean absolute error. These three regression loss functions are there. Loss, that means a error. You are calculating error over here. In order to calculate the accuracy, what we are using? We are using called as the R2 score. So R2 score will give you the accuracy in terms of a percentage. Suppose if it is a 0.92, what is the meaning of 0.92? Your model is predicting 92% values correctly. Again, another one is their adjusted R2 score that we will not use, but sometime it is calculated manually. With the help of a model, we will calculate R2 score only. Okay, and one more we have seen. Yes, do you remember this? Coefficient of correlation. Yes,
Yes, sir.
Rxy, or sometime it is called as the R value. Sorry,
Sir.
Rxy or R value. What is the coefficient of correlation? What is the meaning of coefficient of correlation? Relationship, right? Na? 0.9. What is its range?
And out.
-1 to
Point.
plus, below -0.75, above plus 0.75. Those are the good values of coefficient of correlation. Why I write this? This is not part of a PPT, right? But I have written this because R2 score and R value is a different. R2 score is used for the checking the regression accuracy. Regression problem accuracy is calculated with the help of R2 score, that is R square, and this is the R value. No, just R. That is a coefficient of correlation, relationship between X and Y. That's all. So this is all a theoretical part related to linear regression, guys. Is it okay?
Yes.
Yes.
Yes, sir.
Thank you, guys.